Thanks.
Okay. Hi, Binny. Welcome to Winter with Grace today.
Nice to talk to you, Grace. How are you doing?
Good. Okay, so I want to give Ashmead a shout out because he introduced us, and then this week I went to my mailbox. I got the engineering card. It was such a great like card. It's like so thoughtful. But anyway, so I want to give him a shout out for introducing us. And to start the show, why don't we start with you telling the story of how you started Cognitos. I will give the audience a TLDR, and then you can fill me in with the details. So Vinny started Cognito because his son during the pandemic was like asking him about like what should I do, like I'm so bored. But and then like he started like and then Beanie suggests that why don't you learn how to code, and his son started like coding, and he realized that like this like his son was like making the same game he was making 20 years ago using the same language. There should be some sort of like innovation happening, so Beanie started making like Cognitos happen. So I'm sorry that I butchered the story. Why don't you let us know how you got into, starting Cognito? By the way, also your background on, previously you started a very, very successful company. Why don't we also talk about that as well?
All right. Thanks, Grace. Good morning to everybody who's listening in the US and maybe internationally. Good evening. So I'm Binny Gill, founder and CEO of Kognitos. I started the company about 3.5 years ago, although I was working on this idea myself for maybe 7, 8 months before that. My background prior to this, I was CTO at a company called Nutanix for about 8 years. We built cloud infrastructure software, almost like an AWS in a box for the large enterprises. This is before going to cloud was considered kind of safe and okay. Prior to that, IBM Research, another 8 years, bringing flash technology from consumer devices like digital camera. They had SD cards. How do you use that in enterprise scale for storing data, solid state? Now, of course, the whole world is moved towards solid state. It's better in terms of performance, and even cost has improved dramatically. Background is from UIUC, Masters in Computer Science, and IIT Kanpur, India Computer Science. Happy to be here and talk about Cognitos and in general AI, the future of AI, and what's going to happen. How did I start? So, I mean, I didn't have any main idea. Like when I left my previous company, I thought, I'll just spend some time and wind down. It's been 8 years, and I wasn't looking for any idea. But during the pandemic, I saw my son do programming, the same kind of, and he was 12 years of age back then. And I remembered I had done the same kind of game, tic tac toe, 30 years ago. And the biggest realization was the amount of time it took me without internet, without YouTube, Google, was probably a little bit lesser than what kids these days need for their first program. There's too much noise, too much confusion. The books have become fatter and fatter. Um, and my basic programming book was like 50 pages. That's it. And that was enough to write your program. So, less flexibility, you were able to do it. And I was thinking, even though I thought computer science has evolved quite a lot and now it should be super easy, it isn't easy. If I get somebody who has never programmed in a computer and say, okay, go write a game, tic tac toe, it's an extremely hard problem. And and I got the idea from my son, and my son said, look, why can't it simply understand pseudocode English, right? I mean, why do I have to write Python or any other language? And and it was true, because Alexa was already doing a one line in the kitchen: Alexa, do this, do that. I was not writing Python. Alexa could understand it. So how hard will it be for, if you create another system where you can do 2 lines or 10 lines or beyond that? And so I started on that journey, because the whole sort of kick in my butt was, I don't see many people learning computer languages. I did some research there. Only about less than 30 million people around the globe can code or read code and understand. There are 8 billion people. And if you look at something that is also requires some training and licensing, car driving, right? There are 1.5 billion cars in the world. A billion people can drive cars. And when you're driving a car, your life is at risk. Somebody else's life is on the risk. Yet, as a society, we've been able to innovate the simplicity of driving a car. It's not like an airplane cockpit that you need to go for flying lessons. And that's what programming is today. So I wanted to see, can we actually make the machine simple enough that anybody can start programming, like drive the computer like you drive a car. All right. I thought it will be not that hard, even though, my computer science training told me that it might be hard, but I thought it won't be that hard. But the deeper I went into it, I realized that we have to fundamentally rethink all of computer science if you want to solve that problem. Every decade in the 60s, 70s, 80s, people have tried. COBOL, Common Business Oriented Language, it started off with like, hey, we want to write English like language for business people, but it evolved into something completely mathematical. Um, so there are a few insights along the way, but anyway, that's how it started. It started during the pandemic. I wanted to see, can we make a language or a programming paradigm for a billion people, not for 30 million people out there. And yeah, now we are sitting at a time where the whole world is now demanding that to happen. Of course, there's LLMs and chat GPT, all of that is telling us, hey, computers can understand English. Now, can they actually understand programs, formal programs that will deterministically run? That's what Cognitos is about. So happy to be here.
Amazing. Okay, I want to say hi to the audience. Hi, Teddy. Anyway, so I wanted to learn more about like when you are thinking about nowadays, like as a non-technical person, we could use ChatGPT and equivalent to code, right? Like and to generate code. What do you see as like challenges? We chat about like debugging before, like or just like kind of like monitoring the process if something is happening wrong, like you will be able to know which process was wrong, and then there's a lot to go around that. So I wonder like how would you like what is the differentiation between Cognitos and the current existing tools?
Yeah. Anybody who has worked in the software space and wrote programs in production and maintained them, they understand that writing code is just maybe 5 to 10% of the job. um, you know 30-40% is actually debugging what happens. Hey, this customer saying I was running this and I hit this problem, go debug. Debugging is extremely hard. Not only you have to understand the code, maybe sometimes it's not your code, but you have to be like Sherlock Holmes trying to piece together the puzzle, like what really happened. That's debugging. And then after you debug, you have to go back to the code and add more code to it to make it more robust, so that the next time this happens, it won't crash in the way it did. It'll actually become, it will solve the problem like you wanted it to be solved, right? And that software development life cycle continues for kind of eternity. It never finishes. The long tail of weird cases that you can hit is infinite. Oracle database today, after decades, still has thousands of engineers fixing bugs in the old code. Now, of course, those bugs become rarer, corner cases, but that's because it's a very contained environment. Think of the real world out there. If I say, hey, Benny, um, you know, get me coffee from the kitchen, I mean, it's a simple program. Get me coffee from the kitchen, but I could slip on the floor, or maybe I reach the kitchen and it is dark because it was night. I never thought that, hey, somebody can ask me to do it at the midnight, or maybe coffee is missing. Then I have to write another piece of the code to get coffee from the store and all sorts of things, right? That program never ends. Okay. So now coming back to the thing, if large language models, generative AI can generate code for you, that's solving 5 to 10% of the problem. Can any kind of AI system help you debug, troubleshoot, write new code, all of that? That is an extremely hard problem. It's not yet solved. Um, but I had a bigger insight, an aha moment, actually, when I was thinking about this problem. I was thinking, like, how did things work before computers existed? Because that is where, actually, as a society, we will go once computers become indistinguishable from humans, right? Because then we need to go back to the world where everybody was a human. Now, machines also are like humans. So, how did it work then, right? What was programming? You know what, programming as a word did exist. I have a event, a fair, a wedding, a party, and I got a programmer, a wedding programmer or somebody. What is that programming? That programming is the step by step instructions of what needs to happen in that program. Okay, at what time. And then there could be some notes like, oh, and if this we run out of napkins, then we do this and all of that, right? That's the program. Who ran that program? Another human would go run that program. Say, I'm doing this, I'm doing this. These are coordinators, right? Event coordinators, and they just go and do that job. If anything happens, what do the humans do? They don't crash like a machine. They don't say syntax error or variable not found or something like that. They at that time get creative and then say, how can I address this problem so that I can continue with my program? Okay. That one thing in the last 70 years of computer programming has not been solved. Computers were not built to do that. And that's what Cognitos is the first time we have put that in an interpreter for natural language, where if you get stuck where a normal machine would have just crashed, this interpreter reaches out and say, hey, let's get creative. Let's figure out how to move ahead with this. Now, Grace, that does? What that does is, now suddenly you're less worried. It's not like you're sending a rover to Mars and you have to think through all the edge cases because there is no way of fixing that once it's there. It's not that way. Most humans are very good at handling situations when they happen, right? And therefore, if I hire an intern, I tell the intern, hey, here is a stack of papers, you got to do this. And anything where you're confused, come back to me. That is the interaction that now we will get into with technology like Cognitos with machines. Like, I've explained you something, this is my quote unquote program, happens to be in English, but I want to think of you as a smart human, a diligent intern. You do that, any question, come back to me. And I have few options. If I think that, hey, how can I explain this to you, it's too much to explain, let me just do it for you. That's one option for me. Managers do that all the time. Or if it's a very trivial thing, intern comes and says, hey, I don't know, like, you told me I need to get social security number from this place, but this one is not a number, like this is something saying TBD, whatever. What do I do? I say, okay, in this case, you just put a 99999 or 98. This is how we do business. Just put something. The intern says, oh, okay, so from now on, should I always do that? And I say, yes. Now I have taught the intern another piece of the coding puzzle without really being programming and programmer, right? That is the crux of the problem, actually, Grace. Software engineering, and why software engineers are both rare and highly paid, is because they are doing something that's inherently very hard for humans. It is not natural at all. And that is the barrier we need to cross. We need to get into natural programming, not computer programming. Computer programming is always going to be stuck at a few million people around the world who really like to do it. But a lot of smart people in the world would not like to do it.
Mhm.
But a 2-year-old human being will pick up a natural language. We know
Mhm.
that. So imagine computers understanding natural programming rather than some computer programming. Now suddenly you open up the gates for everybody, right?
Mhm.
And the power is immense. I'll give you another analogy to explain what is the future I'm thinking about. Like, why computers have been dumb for the last 70 years, because of the way we thought computers should behave, as subservient to us, as less intelligent than us. But natural language, the way nature has evolved, is very interesting. I'll give you an analogy. A 2-year-old baby wants to program the parent to pick up a balloon from the desk and hand it over to the baby. All right, this is the programming that the baby needs to do. Okay. Now, the baby knows one programming language, which is natural, but knows very few words, doesn't even know the name of the balloon. How does programming happen in that situation? The baby starts crying. Crying is the most fundamental programming language. It's natural language. Most fundamental animals do that, humans do that. Now the baby is crying. Now there is a quote unquote interpreter computer, which is the parent's brain, right? So the parent is like, oh, I'm getting some instructions. The crying, it's highly ambiguous, but this is how nature has evolved our computer here. Somebody else wants to program us. We, instead of saying, sorry, syntax error, you need to go into STEM lessons or computer science lessons and come back to me with more crisp instruction, nature has evolved us to say, oh, let me figure out what is the situation. So the parent looks around and say, oh, there is a lollipop there, there's a balloon there. These are objects of interest probably, and then picks both of them and says, hey, do you want this, do you want that? Okay, now the baby doesn't know programming language, says, points to the balloon, and that says, okay, here you get the balloon. Now now the parent has now understood, okay, out of these two objects balloon is more interesting. So 2 hours later the baby cries, you say, okay, maybe you need the balloon, take this. That's learning. Okay, computers have not done this so far. We are going to change it. Now imagine the future, right, where instead of blaming humans that, oh, you need to learn computer science, that is your fault. No, let's go fix the machines. Now the machines have to be smarter, and that's what generative AI is helping us. Now machines can go and create clarity without forcing somebody to learn the language of the machine. The machine is learning the language of humans. It's pretty exciting right now.
I wonder, I wanted to ask, okay, so one thing you mentioned, 5% of the job of human coder is coding and 30 to 40% is debugging. What is the rest of the, I would say, like the 60% of things that
Oh,
programmers are doing?
so after the debug, they go write more code. That's
Okay.
the remaining part. So what does everybody do is like, you create your like I'm creating a startup right now, right? So we
Mhm.
had this minimum viable product and shipping, right? Since then, what are we doing? Oh, somebody finds an issue, we go fix it. Now fix it, you add more code and more code and more code. What are we trying to do? We are trying to create an instruction set that is highly complete, and anything that can happen in the world around it, there is logic to handle it, right? That's what we are
Mhm.
doing. Humans are the best exception handling machines out there, right?
Mm,
And machines, on the other hand, are very different. One big sin of computer science I'll talk about, right, which is fundamentally we want to change it, and this is as follows, right? I'll give you multiple analogies. I think analogies help people understand very easily. The best program ever written that had zero bugs, has worked across decades or maybe even a century, is grandma's apple pie recipe, right? Step one, step two, step three, step four. It's a program. Okay. Grandma wrote it with some pen and gave it, handed
mhm,
over to people, and it has been executing on various hardware, various software. Everybody has run that in the kitchen. Nobody filed a bug report to grandma, right? It was perfect. How is it perfect? It is perfect because it does not tell you that, oh, you need to turn the knob of the wolf oven by 270 degrees, right? Or whatever, right? It does not say that, because that's a situational choice. You are supposed to figure it out. Okay. um, it talks about what are the main important things to be done. Okay. Now, supposing somebody was making the apple pie and then there was a fire in the kitchen, whatever, right? They don't go back to grandma and report, like, hey, you need to fix, now write this in your recipe, that if something happens. But that's what computers are. In computers programming, unfortunately, anything bad that can happen in the universe that affects the execution of the program, you have to write it in the program. Okay. That is what happens over time, and this program becomes more and more complex. And if you look at it after 10 years, you don't even know, oh, it's apple pie recipe, you wouldn't know. It'll like, oh, it talks about firefighters coming in, it talks about spills, and talks about all sorts of things. What am I really doing? Oh, you're making apple pie, okay. That would be like 1% of the actual program that emerges over time. That's computer science for you. In real life, all the exception handling, edge case handling, all the weird situations is not done by the program, but done by the operating system. I'm using a technical word here, but operating system is the system where the program runs. It's the human brain, right? So the human brain is able to run a program and handle everything weird that can happen without the program telling it that, this is how you need to handle it, because we know how to handle situations across different programs. I could be making apple pie, or I could be just, you know making coffee, but if there's a fire, I handle it in the same way, right?
Mm.
That is the beauty, and that's why I called Cognitos an OS for cognition, because the real change that's happening is pulling out all the edge case handling from the program and giving it to the operating system. Now, the operating system is getting smarter. It knows how to handle all these weird cases. So now you only have to you only have to write a program that is simple, step by step. Imagine like what IKEA does when you have to assemble a table. They know a human operating system will run that thing. So they never say, oh, if a screw is missing, go to Home Depot. They don't say, if you hit the hammer on your finger, get a band-aid. But that's what programmers do all the time, right?
Mhm.
That's the fundamental shift. Last so many decades, we have been training people in the wrong skill, actually. We got to change that.
Mm. What do you feel like is the biggest challenge when you're creating this? Why didn't anybody else, go after this problem?
Well, when I pitched this idea to VCs, a lot of VCs told me this is impossible, number one. Number two, they said, even if it is possible, you are 7 steps away from a real product. Why? Because you're talking about, you will build a new language, like a subset of English. Okay. You will write the interpreter for it. Then you'll write the development environment for it. Then you'll write the various libraries around that. Then you'll come up with a use case. And then you're going to deploy this for that use case. Then you'll solve a real business pain point, right? And hope everything works. It's like too much risk. So it doesn't get funded. The reason, I mean, of course, I got Ashmeet and he's like, Benny, there is something here. I can tell you. I said, good. I just need one person to believe that. But people have tried this as well, Grace. It's not like in the 80s, people tried 90s. Donald Knuth, who I highly respect, it's a professor at Stanford. I read his books when I was young. He also tried it. He created C Web. Um, the challenge back then was compute and memory was too expensive and too limited. So even
Mhm.
though people had ideas, they couldn't really execute on this thing. So it was just a matter of timing. That now we have enough compute, enough memory. But most important thing that changed, because the chat GPT is now, people are saying, yeah, it needs to work, which is good. Because 4 years ago when I was talking about it, nobody said it needs to work. It's like, okay, if you say so, but who's going to use it? Why will they use it? Because developers uh, are used to doing things in Python and all of that. And my point was like, no, it's not for developers, it's for the rest of humanity. um, and now it is so critical that we have this. It's not even for making development more efficient, it's actually to make humanity safe.
Mhm.
And I mean, if you want to talk about that, let me explain it a bit. AI, generative AI, and we are saying we'll reach AGI and go beyond AGI. Fine. That is a machine at the end of the day. And then all our computers are also machines, right? Where they connect to the internet, everything that we do through computers, whether an API call or something, that's also a computer. Now, there are two computers, the AI creative computer, and then our traditional computer science diligent computers. The two want to talk. That's what's happening right now. AI, generative AI, is generating stuff and humans are looking at it. Oh, maybe it wrote an essay or a letter for me. What's happening right now is AI is going to create programs, as you're saying, and that program will control our business machines or our military machines or anything, right? Okay, imagine that's happening. What is the role of a human, right? If the role of the human is not much, because AI, the billions of GPUs that will be out there, they'll be generating so much planning, so much program that humans cannot review it. Just because already the number of developers in the world is extremely limited. Now, how many people are there who will review the code that AI generates so that to make sure there is no bias, hallucination, and it is safe? In fact, that's a massive bottleneck. We won't be reviewing it much at all. So then what is the natural thing to do? Why is a machine trying to speak in a language that 30 million people understand, only to then convert it back into assembly code or something that a machine understands? AI would simply say, let me just talk to the machine in assembly. It's fast and it's whatever. What's going to happen is that we're going to bypass humanity, and there would be no possibility of reviewing what's going to happen. And that is when GM Cruise, like, accident, when that happens, you question, AI made a mistake, or was it intentional, or whatever. How does humanity deal with that when AI makes a mistake, right? It's a bigger topic. We can get into that if you have time today. But I want to paint the alternative here. The alternative is, instead of worrying about there are only a few developers who could review the code that AI generates, let us change the language of the code and say, oh, a billion people can review that. Okay. So have AI generate program like it used to be before computers existed, step by step instruction that anybody who was a wedding programmer or an event coordinator who could understand that. Now that's in English. Have them review it. Now, after they've reviewed it, it goes to a diligent system, and that's what Kognitos represents. That diligent system is going to run it. Now, this diligent system is unique in the sense that this grandma's recipe or whatever you have could have some things that are yet not expressed clearly. Hey, what do I do in this situation? This diligent system is going to ask back the human, hey, in this case, what do you want me to do? And then learn from the human. So it is still quote unquote programming, but a more natural programming where a billion people are in control. And that is the way I believe that the world can use AI, even though AI is super intelligent, beyond AGI, in a safe manner by making sure humans are. The analogy I use is they're in the driver's seat, and this is the steering wheel. The program in English is the steering wheel for all of humanity. A billion people could steer that if they want. They could also put it in autopilot mode where it is running by itself, but anytime they feel uncomfortable, they can grab the steering wheel, they can understand what's happening and change it. So that is the biggest reason why you need a language where machine and human are on the same page. Extremely important, because that way all of humanity can leverage and use AI in a safe manner. It's all about, hey, AI, yeah, you can drive the car. Hey, wait, I'm not comfortable on this street. Let me drive, right? That is that interchangeability of what the machine does and what the human does in driving the same steering wheel. That works. It cannot be that, hey, AI, you drive and you're writing some weird thing, and I cannot even budge in and actually take over. This is humanity losing control over our environment, and that's a pretty hard thing to make safe.
Mm. I wonder. So I want to talk. Oh, I want to touch about like the business side a little bit. So you guys are serving, logistic and supply chain, manufacturing, banking, consumer packaging. So like I guess like when you are thinking about the use case, who do you go after first, and then what does the enterprise sales channel look like? Since like I really believe in your vision. I think it's very I see like the world is moving to that direction as like the non-coder people could be able to program interesting things. I wonder, like, how are you executing from the business standpoint? Because eventually to achieve a unicorn company or achieve like some sort of exit, it needs to generate profit. And I wonder what's your thinking framework on letting regular human adopting this technology.
Yeah, of course. So we've been in business. We are making money, doing really well on the business side. Our main customers are Fortune 1000 companies that are pretty large, and then they have a large workforce, typically doing manual activities around moving money faster in the business, like in the finance department, invoice payment, purchase orders or payroll, and um, there are a whole bunch of processes that businesses do, especially the larger businesses have a lot of people doing that, whether it is outsourced through a GSI or just in house. Now, the reason why humans are involved is because those activities are not cut and dry like a math equation. Those
Mhm,
activities involve dealing with their customers and partners and third parties. And then there's always this thing about there might be an edge case. Oh, the CFO told me in this case you have to give the discount because the CEO said. There's an edge case. You can't foresee all of that and put it in a program. So for the last couple of decades, even though there have been technology like robotic process automation and a whole bunch of things, but those are the old way of thinking about programming. And imagine if just writing a database takes decades, writing an automation that represents all the nuances of how the business operates. I mean, that's extremely hard because the nuances of how the business operates keeps on changing according to market, according to leadership, all sorts of things happen according to the tools you're using at that point. Extremely fluid environment. Therefore, there are thousands of people. In fact, if you add all of the GSIs and combine together, hundreds of thousands of people are doing manual business processes today. Okay.
mhm,
Now we go and say, yes, there are humans doing it. Is there a way for you to describe what these humans are doing in a simple way, like a grandma's recipe way? Like, oh, step one, step two, step three. And the answer is yeah. I mean, most of the work that they do, like 80% of it, is simple. All right. So the remaining 20% is always these edge cases, and oh, I need to call the boss, I need to do something great. We say, look, take that 80%, let's write it down in English,
mhm,
then Cognitos will run it for you. And they're like, okay, who needs to write it? I'm saying, no, the person, just one person in your company needs to write it, right? One person who has a bigger picture point of view. Normally, these are the people raised before computers existed. They were the people who wrote the employee handbook or the standard operating procedure for the business, right? A VP of finance or whatever. And they'll say, this is how we want to run our business and hand it over to people in the company. Get that person, not a developer, but a programmer. The old definition of a programmer, a person who can think logically, step by step, and write stuff that humans will understand. Okay. Now, that program is also what machine understands. That's the difference. Now, Cognitos is running that. Say you're processing 30,000 of receipts or 30,000 claims or prescriptions a day.
mhm,
Instead of humans doing all of them, Cognitos does it. And of course, there is document processing involved. You have to read um, a picture. Now, somebody took a screenshot with their cell phone and uploaded it. Hey, I want this reimbursed. Fine. So you do that. Now, it's not black and white. That thing is like, oh, I might still have questions and all of that. Cognitos is doing that. Anytime there is a question, just like a intern would raise their hand and say, I need help. At that time, it goes to the person or the staff who do it manually. The hundreds of people that mostly all these companies have, goes to one of them. Hey, this Cognitos intern needs your help. You normally do like 1,000 of these a day or 500 of these a day. Can you help with this one? Seems like a little bit more complex. Okay. Now, this person says, okay, they need to understand what's happening. And that's the fundamental shift. When we say debugging is hard, it's hard because you need to have a developer look at this and stitch together what really happened. In this case, this is English instruction. Like, it's like grandma's recipe. You're on step 5. I can see, read the English, and I can see the cooking pan, what's happening. I know this is where you are. Okay. They do the same thing. You were there, you looked at the document, you're trying to get this. Oh, this is where you're stuck. They say, let me take over the cooking for you. That's one option. Like, okay, I'll take it over manually. Thank you for doing the remaining 80% for me automatically. I'll take this manually, right? Or they'd say, here is the answer, okay, and this is how I did it, but take it from me now. You don't need to learn it, but just continue, right? Or the third thing they could do is they can actually teach right away, like, this is how it is supposed to done, and then the system learns that. So that's how we are approaching the problem. It's mainly talking to the person heading finance or person heading process automation in large companies, and helping businesses move money faster. And if you do that, there's money in moving money faster.
I'm literally taking notes. Okay, so what is, I guess, like, per to our chat, I watch some videos on your website. Basically, for me to describe to the audience who are listening, the like how it works in my perspective is like you go to the playground and then you type in like all the procedures that you would previously documenting to maybe your intern or like your team. Here's like what we need to do, A, B, C, D, E. And like if XYZ happen, you do XYZ. And then the machine is like generating code. And then there's like something that helps it to create like a program that would happen. So I wonder, how is this like integrated with the existing engineering team? And how, or like is this like a replacing the full on engineering staff to like to a regular traditional business that's not technical focused? And I wonder, like what does a competitive landscape look like for you in this space, of I consider it as like a no code movement. I know that you probably don't identify this as a no code movement, but like I feel like this is like kind of shifting towards like people who, yeah, it's like a kind of like a no code too, to a degree. Yeah, like I wonder what is like, the technical mode and competitive landscape look like in this domain.
Got it. So you had two or three things there. A couple of those things I have to correct, like what words you used and what they mean.
Okay.
Okay. So first, let's talk about, you said that they go to a playground. Now, the reason we have a playground is, in my experience, software development is hard because you write code in the abstract and then you run it with some real data. Okay.
Mm-hmm.
Then you realize, oh, it didn't work because the real data had this and that. Okay. That's hard. How do humans learn? Somebody holds your hand. It's called hand holding. Okay, so the manager comes and says, okay, we'll do this work. Okay, do this. Now do this. Now do this. And they're observing every step of the way. And you are also observing where you are. So you have to only take, some leap of faith insight for the next step. That's it. Programming, on the other hand, is 50 steps in the abstract. Okay, extremely hard. That is why the playground is there. The playground is for doing one step of the automation at a time while seeing the results as they are coming in, makes it super easy for people. That's the only way to do, real. And in fact, if you think about what Jupyter notebooks did, that's precisely for data scientists, guys. Like, you need to see as it is happening. Don't write massive programs like that. So it's like Jupyter notebooks for the business side. Okay, that's number one. Number two, you said we generate code. No, we don't, because you just cannot. So when you say, hey, make apple pie, I don't generate code first and then get into the kitchen because I don't know what code to generate. Will there be a fire? Will I need more sugar from the store? Will I actually slip on the floor? I mean, I don't know what all code to generate. It's infinite. So it isn't that. I mean, and then it's very hard for me to explain people, even people from computer science, that the traditional notion of compiling logic is fundamentally wrong. Human brain says, I'm going to do it and then figure out what else do I need. So I just go into the kitchen first. And then I'm looking at stuff as I'm doing things, as I hit issues. At that time, I generate a plan. So there's no generation of code. I generate a plan. And sometimes I need help from somebody. Hey, I need money. So I ask somebody else. So that's the other thing. It's a fundamental difference in how normally automation has been done so far. Um, okay. Then there's one more point you mentioned around. Can you repeat the last part of the question you
Yeah.
had?
So what is like the technical mode and like how like or like the competitive landscape in this
Got it.
entire area? Yeah.
Yeah. So now we are taking this and we are actually, we do use this word of, we don't need technical people or this is no code. Here's what I want to say. We are saying we need a world of natural code, natural programming, right? It's extremely important because if you talk about this whole journey of, there used to be programming languages since the early 1950s and all of that, and then no code, low code, visual programming appeared. By the way, they appeared Visual Basic and all of that 20-25 years ago. Today, I don't use visual programming. None of the developers in my office use visual programming. For kids, there is Scratch from MIT. Kids, when they grow up, they stop using visual programming. What's wrong? You know what's wrong? The visual stuff is to make discoverability easy, but it limits the flexibility that you have. And if you want more nuanced stuff, then it actually comes in the way. Normally, when humans talk to humans, we use language. We don't use visual drag and drop. When humans talk to computers, we use language. We don't use drag and drop normally. If you want to do real, nuanced, valuable stuff, you use drag and drop when nuances are not either allowed or important. I go to McDonald's and I say drag and drop this, this, this. They won't allow you to do anything special. All right. Now, in the business world where real money is involved, nuance is the name of the game, right? I mean, every business has very unique requirements and all of that. So that's why you need nuances there. So no code isn't really something of great value to a business. It's natural language, and that's what we need to do. Now let's talk about what are we providing here. What we are providing is a machine where the core language of not only programming, which you can get with Copilot and all of that, but more importantly, debugging, troubleshooting, and the ability of not even having to write all the edge cases up front.
Mhm.
Let the human do it. That is what we are providing, and that is the quote unquote moat of how to do that. And that moat is pretty significant because it isn't something you can layer on top of an existing language interpreter like Python or Java or C++. You cannot layer it on top. I mean, you can have an LLM generate Python. What happens if Python 50 lines in the deep there has an issue? The only option you have with Python is you have to start it all over again. So what if, I have to onboard an employee? First step is to order a Mac laptop for the employee, and second step, blah, blah, blah. And then I hit a problem in sixth step. Now, okay, Python hit an error. And I say, okay, I fixed the problem. Now start again. I'll order another laptop. That I don't want to do that. So you need an interpreter that will say, okay, I'm at sixth step. I'll reach out and ask for help and figure out how to move ahead. None of the programming paradigms out there support that. That's why we had to build an interpreter from scratch. It was extremely hard. And that's the core fundamental kind of moat, if you will. Obviously, there's a whole bunch of other things we have, and we patented stuff 3 years ago. But fundamentally, it's all around making the edge cases, exception handling, a first class property of the operating system so that your program is extremely simple, right? Today, if you go and ask a generative AI engine to generate code, it will generate in the traditional way. And the
Mhm.
traditional way is that all your edge case handling is right there in the code. And then it's just not possible to write the million lines for doing something simple. You need actually an interpreter engine that is smarter than that. So that's what we have.
Mm. Okay, I'm taking notes. Interpret engine. Um, I guess when you are building it, like, so are you do you feel like you're creating a new category, or like if are like, I guess, like, what is the old way people are doing it, and what are you replacing?
Yeah, I mean, fundamentally, if I zoom out, we are changing computer science fundamentally. Computer science is the science that says how do you translate something ambiguous in a human's mind into what a machine can run. That's computer science. We want to say that now, instead of translating what the human had in their mind into a language that is very rigid like math, have an interpreter that can actually deal with ambiguity and therefore be closer to what the human wants. So this is the new platform for writing applications in the future. Um, so imagine business applications that are written all around the world. I'm not talking about databases or operating systems and those things. We can still have developers do it in the traditional way. But I'm talking about like a VP finance says in a large company, Fortune 500 company, hey, I need this app because I need this report, that report, and this thing. I need 5 actions. There are thousands of custom applications that large companies write because there is nothing out there that suits precisely their need. Those must be written in English, and they should not need any developer from IT. They do need natural programmers, which, by the way, the business has. When the VP of finance is saying, I need that, you know what IT says? Can you write a description document of exactly what you need? Because we don't know the business logic, what you need. And the person in the business side writes the document. This is what I need. That is natural code. That is why I think no code is not needed. Now IT takes that and converts it into some kind of weird no code stuff, and that is just translating to what the machine will run. If the machine is smart enough to understand what the business side said to IT, then you cut all that crap out, right? So that is what's going to happen.
Mm. What is if your business fail, what would the reason be?
Well, I normally, I mean, I've done multiple startups and all of that, right? So the first startup failed because the dot-com market crashed, right? Sometimes there are macro reasons, but most of the times startups fail because of internal issues. Um, I mean, assuming everything else you got right, right? People, process, and the product, right? Most important thing is the people. What kind of people do you have? Do you have people who want to do the right thing for the customer, not necessarily they have their own? Like a lot of the startups these days is, okay, I have AI, where can I apply it? That's the completely wrong way of doing any startup. You should start with, I have a pain, how can I fix this problem? Doesn't matter what technology I use. That's the right way of doing it. So if you start with a pain, and I'm starting with this pain, I want 1 billion people to be able to drive computers. That's my pain. Whether I use generative AI or I use 1960s compiler design, doesn't matter to me. Okay. So that's fundamentally most important thing. Is the pain you're solving a real problem, a problem that will sustain? And if the pain has been there for the last 100 years, it will be there for the next 100 years. That kind of thinking. Okay. Shouldn't be like a pain that emerged just last month. Like, oh, I need to do some rag thing that emerged just last month. I mean, it'll go away after 1 month. I mean, how do you know this will? So one is the problem statement. Is it a deep enough problem, a large enough problem, and also impossible problem? It should not be something obvious. If it's obvious, the incumbents will anyway do it and you will be out of business. Has to be something like, really, people should say you're crazy, then you have a good idea. Then you get enough more crazy people to work with you who don't like to fail. Fine. Then you have to make sure that you the keep the culture of the company intact. There will always be ups and downs for a startup. When the down days are there, the team needs to come together and say we will win. Okay, those things are important. Okay. And at all times, focus is on the customer pain, and if technology changes or something changes, you have to change. There should be no religion that sort of keeps you blind to what's happening. So you do all of those things right, still things can fail, because macro changed. uh, some company sues you. I mean, all sorts of things. I've in my lifetime, I've seen enough reasons why you could fail, or you make a big blunder that's hard to revoke, right? Security breach, whatever. So there's so many reasons. I mean, in a startup, and it's just like when I'm talking about software programs. Software programs can fail in a million ways. Companies can also fail in a million ways. So why would it fail? I mean, I can list an endless reasons why. Why would it work? I can give you a few reasons why it would work. It's the culture and the people. That's why it'll work. Everything else is a derivative of these two things.
Um, I guess I wonder, in terms of culture and people, what are your core philosophy on that? How do you create a culture, and what culture are you trying to create?
Starts with the focus on the customer's pain and solving for the customer's pain. Extremely important, never to lose that focus. The customer will not actually give you the right way of solving the pain. I mean, they'll maybe ask for a faster horse or something like that. You can build a car, doesn't matter, but you need to make sure that you are keeping in touch with the customer. So at Cognitos, we therefore have a very flat environment where everybody is in direct connection with a customer, one or two customers, so they know and can have full empathy for the customer. That's number one. Number two is empathy, not just for the customer, but empathy for your partners and peers, so your colleagues. One thing we hold in high regard is, what does the team think of your work? It doesn't matter what the manager thinks, but what does your team think? So we use various internal tools to measure that in a scientific way, and people get feedback, and that way team playing is being a good team player is extremely important in the culture. So all geared towards helping the customer, right? And obviously integrity and other things. I mean, those are pretty standard, but if I have to highlight a few things, these are the couple things that are really important to us.
Um, I wonder, how do you answer the question why you, when VC asks you like why you're creating this?
Because see, frankly, when I started this, I did not know that it will work, right? So why me? So you need somebody who has spent enough time in computer science and is willing to give up on all of that, right? Everything that I am currently doing is to undo what I learned in IIT Kanpur computer science. Like, hey, this is how compiler should be done. You think about optimization and all of that. It's like out of the window. I'm not even generating code. What do you talk about optimize? Like, if I have to go make again pie in the kitchen, I'm not thinking how to optimize. I mean, that I'll do after running it 1,000 times. The first time, I don't do that. So so you need somebody who has nothing to lose, both in terms of, in terms of time, money, anything, credibility, nothing to lose. That's number one. Number two, somebody who is sort of doesn't think that the current way of doing programming is why they are great. I never thought that I was a fabulous programmer, right? So I have nothing to lose saying that, hey, the old way of programming is actually bogus, right? It's the wrong way of doing it. I want to come up with a new way. And by the way, so this way of programming is what I really yearned for all my life. Like, I want this because I am a good planner, programmer of the old style, right? And that's why, as a company, I can run this company with a lot of ambiguity. Every there, there's too many things that are unknown, but when the problem happens, I can address it. And I want to think about it, even machines, that way. And then why me? It's actually the real answer, Grace, is it isn't just me, it is the people who work with me, right? So why me is because I can ask for favors from other people. Hey, can you please help me build this company? And they come and join the company. If it was just me, nothing would happen, right? I would still be, creating, tinkering with my cool idea. It's about gathering similar minded people who probably didn't have as much of a risk appetite like I did, because I had nothing to lose. Other people do have things to lose. I mean, they still want, early in their career, they want to still make millions and all of that. My job is to make sure that happens for them. So yeah, and of course, why not me is what I normally ask.
I wonder, what does a back end look like when you're building this thing?
Yeah, so it's a massive serverless farm. Currently, it's running on AWS, um, where this RPA world is all about. I have bots that I have to maintain, and these bots run my automation. This is completely serverless, so you can run a million of them one day and only 10 the next day. It doesn't matter. It highly scales. Um, so this serverless architecture is a platform that runs natural language programs, right? So it's almost like an interpreter layer that can scale as much as you want, and it's running natural language programs. Um, it has connectivity to talk to the user over email and over the UI, but it also on the back end, it has connectivity to all the CRM, ERP systems, productivity suite from Microsoft and Gmail and all of that. Like that's the south, it can connect there. Um, the interpreter itself, I mean, that has deep learning, generative AI, compiler and interpreter design all put into one, and that's the core piece. That is our core IP there. um, yeah, and we have deployed this globally, and people can invoke this through various ways, like send an email. So every automation that you write has an email address. It has an API endpoint. You can do it however you want, or you can schedule it and run it. um, the difference between earlier technologies and this one is this can communicate with you like, hey, I need help, and I continue. So that's all. Yeah, a lot of it is in Python. If you're interested in the language, although eventually that language shouldn't matter, whatever it is. But yeah, bunch of the latest and greatest in AI comes in Python. So we just decided that we'll just start with Python so that we can move as fast as the world is moving, incorporating the latest and greatest. Right now, we are obviously we're partners with OpenAI. We have access to things that are just going to come out. Um, Multimodal vision models is what we're already deployed with customers. Those are doing amazing. Um, then yeah, fine tuning various LLMs out there, and seeing how we can bring the power of AI in a safe way to enterprises.
Mm. When you are hiring the engineering talents, what are the things that you would test them for?
Ah, biggest thing is design skills, right? Because I fundamentally believe that writing code is something that's going to get optimized and simpler. Now we need to be hiring for a one level higher. Almost like every hire that we do is for a tech lead kind of position. um, and internally we use a whole bunch of accelerating technologies to write code, right? A lot of us don't even write code manually right now. It's all generated, and you just have to think like a tech lead. So the primary thing is, okay, let's go design something. Okay, so we have to build this product. I won't give you the exact interview questions because people are seeing this, but we have a few questions and we talk to people and we know how to compare. So that's one. The other one we are trying to tinker with a bit is, let's write code, but here, ChatGPT is there. Let's see how fast we can write something more meaty. Earlier interviews, back when I used to interviews, okay, reverse a doubly linked list or something, or singly linked list, that kind of stuff. It's no longer interesting. Now it's bigger problems because we have generative AI. How can you leverage this to go faster? So that's on the engineering side. On the non-engineering side, if we are hiring a person on sales and solution engineering, it's all about, can you learn something new, net new? Because what we are selling is something that doesn't exist. um, so how do you learn some new technology faster? That's important. On the engineering side, the other question is, can you unlearn what you have learned in the past? That's more important. But yeah, in general, we're looking for, you know 90% of our job is actually data. Believe it or not, it's like we are not stateless. We collect a lot of data, and that feeds into learning and all of that. So we have a bunch of data, large scale data engineers, not data scientists. It's like people from petabyte storage background, right? Storage in the cloud, that kind of stuff. um, so those are the things we look into. Distributed systems knowledge quite a lot.
Mm, amazing. Okay, so uh, I have so many more questions, but I want to be mindful of the time. I want to end with like a 1 minute fire chat with you. What's your favorite book?
Brief history of time.
Who made the biggest impact in your career?
My career, actually, the first mentor I had at IBM Research, the first day I joined, there was a guy, Nimrod Megiddo, and he said, Binny, you need to just write 5 papers. And I said, oh, how many have you written? He says, I stopped counting, like 200 plus journals and books and all of that. You just need 5. I said, how do I decide those 5? Like, should they be best papers or whatever? He said, no, those 5 would be still being used when you retire. Because he was retiring, I think. So have real impact on the world. That was the biggest thing on my first day in research. I could have gone into complete research land and papers and no impact on the world, but that changed it for me.
Mm. Um, who would you invite to your dinner party?
Ah, I am a big music fan. One of those good music, Taylor Swift won't come, but maybe.
I can't believe our conversation will involve Taylor Swift, but anyway.
but yeah, somebody like that would be really nice.
Okay, amazing. Where can we find you outside of work?
Sorry.
Where can we find you outside of work?
Outside of work, movie theaters. I like movies. I like watching movies with my kids and family and friends, and also at in our office we try to go and watch. Dune 2 is next. We got to do that. It's on our list.
Amazing. Well, Beanie, thank you so much for coming to the show today.
Thank you, Grace. Thanks for taking the time.